Great. All right, thank you everybody for spending the time this morning. I'm glad the lights are on, otherwise we would have to do this in the dark. What I want to talk to you today about is service chains. So the background of this is this is really an application talk as opposed to a more technical talk. And what we wanted to talk about is Radware offers two sets of solutions. We offer a virtual-based ADC for load balancing and service chain, and also virtual security software. And specifically, what we're working on is we're working on virtual ADC for service chains. And why are we doing that? Well, we're specifically doing that for a lot of Tier 1 carrier customers in 5G mobility. And the reason for that is really encapsulated in this diagram. This is a network slicing diagram that comes from Ericsson as one of the major architectures that a lot of carriers are looking at deploying going forward with regard to network slices. So you want to imagine a world where moving forward, carriers are doing two things. First of all, they're moving everything from network proprietary-based hardware infrastructure, which is primarily how their infrastructure is based today, to cloud-based infrastructure. And then second of all, they're looking at moving to a network slicing type of model. So this is on an application by application basis now. I can virtually spin up instances on all of the different major services in the chain and then give different priority, different bandwidth, different latency, all sorts of different characteristics, different security, all different characteristics depending on the service and what I'm offering. So to give you an example, IoT is the great example that gets used in this application a lot. If you compare, let's say, for example, a smart metering type of application where bandwidth and latency might be less important to a real-time imaging, some type of e-health functionality, where much more bandwidth is going to be required, especially if it's a video feed, and certainly latency, when you're talking about a health application, becomes critically important. So this is a great opportunity for the carriers, particularly around the wireless side, to migrate to cloud, to use platforms like OpenStack and OpenDaylight to move their infrastructure to this and give them the dynamicism in order to be able to provide these network slices. So what is Radware proposing? Well, we're proposing taking our high-capacity ADC with the ODL framework for service flow chaining and then mapping that information model from ODL service flow information to Alteon steering rules. Right, and Alteon is our ADC application. Now, why do we want to do that? Well, there's a couple of reasons that we're proposing doing this. The first and foremost is there's huge cost savings associated with doing this. So we have a virtual NFV-based load that can run on OpenStack that can do about 200 gig in a single server. And so 200 gig of layer 4 load balancing. So when you compare then now that from an ROI perspective to the network-based infrastructure that most of the carriers are using, that's about a 60% savings over a 5-year period. And that savings comes from three major areas. That comes from just general CapEx savings. That comes from OpEx savings associated with the virtual nature of the network now as opposed to proprietary OpEx. And then the third piece is time to market, right? Most of the carrier networks today are set on fixed cycles associated with 2 major loads per year, so 2 major new feature sets coming. And this enables them to be much more dynamic and compete against Amazon and Google and the guys they see as their longer-term cloud competitors in a much more dynamic environment. And so doing that, then we're able to leverage a lot of the Intel silicon advances with things like DPDK and SRIOV and PCI pass-through, et cetera. That's how we get to a 200 gig load. And then that is fully featured with all of our mature ADC functionality. And then what we do then is we take OpenDaylight then as the information model and then map those rules to our ADC steering rules. So this is more of a network diagram view of what we're proposing. And what you can see there, then the network devices are virtual ADC, which can run on basically any white box server then, and we can orchestrate it using OpenStack. And then for provisioning and steering rules then, we create an application agent based on our Altian that basically does the translation then from the service flow chaining in the information model in Open Daylight, and then translates that then to those same sets of steering rules in our ADC. So you say, why do you want to do that, right? And the biggest reason that you want to do that is because this saves a huge effort associated with recreating all of those in Open Daylight or some controller level application, right? All of those rules, et cetera, exist in our ADC already. You can see huge cost savings in terms of revenue and OpEx by moving to an NFV-based model, but you don't have to redesign the whole control plane in order to do that. So the value to carriers, there's really three major value statements that enable carriers to do this. One is enables carriers to focus on innovation, right? We had this same issue several years ago associated with SDN, where we had dumb pipes versus hybrid pipes, and we were going to create dumb SDN switches and then recreate all the functionality in the SDN control plane. This kind of gives you the best of both worlds, where you can use an Open Daylight framework, but you still get all of the control rules from the solutions that are mature and already exist. Second thing is you get the carrier grade scalability and availability. This, again, as we said, this is a 200 gig solution that we can cluster together to achieve more than a terabyte. So it can be used for the largest loads in the carrier network. So this is something that could sit on the SGI, for example, in the 5G network and control all of the traffic coming in and out of the internet, right? So from a carrier perspective, it offers huge CapEx and OpEx savings because it can handle those largest loads, and it's based on a solution that's mature and known and documented, and it's serving today in many, many tier 1 carriers around the world. And then the last thing is it gives this mature feature set. So all of those pieces don't have to be recreated in the control plane. They're already implemented and used in the ADC software that we have today, and it enables us to tap into this idea of network slices traditionally executed by ADC and have all of those same functionality in terms of health check and all of that other things without recreating all of those items in the control plane. So with that, thank you very much. If you have any questions, I'll be happy to answer them in the back. And thanks for your time today.